Today is the day that we get to use the end mill that's small enough to pick Abraham Lincoln's nose. I don't know if that showed up, but this thing is tiny. It's only 10 thou, and we only have 2 of them. So let's really hope they don't break. Also, these parts need to ship today. I did get a start on it last night. You can see here we have our about 2-inch deep pocket and just the beginning of the outside done. The outside of this is very simple. It's basically just a cylinder. The other side of the cylinder is just a different diameter. All of the magic happens way down there inside the cylinder. So this is probably the last time you're going to get to see it because of NDA reasons. But yeah, this thing is a nutso part. And that little tiny tool is making a feature way down at the bottom of this, the cone inside the cylinder here. This thing here is going to be our secret weapon. This is a ER16 to shank adapter for my tool holders. Well, for anything that's ER16. It comes from Harvey, supposedly has pretty good run out, but also they give you 3 sets of set screws so that you can dial in the run out to make sure that it's good. It was expensive. It cost more than like 5 tool holders for this machine. However, for this machine, you cannot get any tool holders except for ER16, which I have a bunch of, and Rigo Power Grip, which I have none of because they're ludicrously expensive and they need a machine that's expensive. So this is the tool holder that I'm going to use. These are the only tool holders that I have. And I could probably make the part with just this, but the tool would have to stick out really far. That collet adapter basically just lets me reduce the stick out while still being able to get into that tight little cone. Step 1 is I'm going to take this tool holder and I'm going to put it in my ultrasonic cleaner. Any little chip that gets underneath the taper of that collet will destroy my run out. So we want to make sure everything is crystal clear, crystal clean, sparkling clean, super clean, so that we don't run into any issues. Though this is where we start to get rabbit holed because my ultrasonic is nasty. So I'm going to clean out my ultrasonic so I can clean my tool holder so that I can make the parts. I just called Harvey Tool about this little adapter, and they say there is no RPM limit and it is balanced. So 40K, maybe 30K. We'll see how brave I get. My machine can do 40K. I tend to not run it above about 30K just for the life of the bearings, and it's an old machine. But for this project, the tool's so small, we may go full RPM. Coolant whirlpool. Nope, don't use that. Inside this nice little coolant whirlpool, I have a ball mill running at the moment. It's doing a boring operation, and that will give us a nice finish, hopefully, inside that cone. So before it was roughed out, you saw with the adaptive step downs. Now we're doing a boring operation to give us a nice, smooth, clean wall. It's definitely not going fast. I'm taking it really nice and slow. This is a long end mill. I just want it to look good and finish safely. The finish on the inside of that cone is okay-ish. It is shiny. I can see my finger in it, but you can also see some ghosting from the step downs from the roughing operation. So I don't love that. That shouldn't be showing up. What I'm going to do, because it's a cone, and I have a bunch of extra stock, I'm going to move my part down probably 5 thou deeper into that cylinder there and redo that bore and face off the top and do the outside and everything. And that should let me just clean up that face again. Basically, this was just a roughing pass, and we will do a finishing pass, which I think will make it look a little bit nicer. That extra finish pass made a big difference, and now I think we're ready to move on to the truly terrifying tools. This one is a 15 thou flat end mill that we are going to be using to rough the little cavity down at the bottom, which we will then finish off with a 10 thou end mill. So the first thing I need to do is get this touched off. Actually, no, the first thing I need to do is dial and run out. Then I'll get it touched off, and then we can move on to see if it'll actually cut metal and not break. All right, nothing too wild in measuring this run out. Obviously, the first thing we need to do is make sure the indicator's touching the tool, and we're just going to do that by hand jogging here. We are going to go into tenths mode because we want to be really careful to not screw up this tool. This is the 15th thou one, so a little bit more meaty than the 10th thou one. 5 thou difference on a tool doesn't seem like a lot, but you have to remember that's 50% bigger than the smaller one. Alright, so we got our 0 reading there, and I'm going to turn on my door override here, and I'm going to spin it at like 100 RPM. Yeah, so that's a wee bit of run out. It's like half the diameter of the tool. Yeah, it's visibly moving. So we need to do some screw adjusting now. So I'm going to stop the spindle here and find the high point, or the low point, which looks like that. I always have a hard time remembering which way I need to move the tool to get the run out less on the dial indicator. A quick easy check is just to kind of give it a wiggle, and I can tell if I push the tool towards me, it comes down. We want to get this closer to 0, which means the tool needs to go that way. So I need to tighten this one and loosen the other 2 little set screws here. Now this tool holder thingy has 6 set screws, 2 on top, 2 on bottom. The ones on top hold the tool in place, and we dial the run out in with the ones on the bottom. Nothing I seem to do is getting this better than about 2 thou run out, which would be absolute murder to this end mill. So I'm going to try reseating it inside this tool holder. I think maybe there's something causing some run out in that joint. All right, that made a big difference. I think the big thing is I switched collet nuts. This is a RegoFix collet nut. My other one was the Haas one. And this thing just fit in there better. I couldn't get it to latch into the Haas one. It latched right into the Rego one. So we're looking at 2 or 3/10 of run out in the bore of this thing, which is actually the spec. And I'm hoping I can get that down by using the set screws. I took the tool out to so I wouldn't break it while I was doing all this. I also started measuring directly from the bore, since that is actually what we care about. We don't care about the outside of this thing, we care about the bore. After far too much tinkering, this seems to be about as good as I can get it. Probably 2 or 3/10, call it 2.5/10, which is still a massive amount of run out for this tool, but I can't get it any better. I'm hoping that maybe the coat on here is a little bit out from the actual tool, and the actual tool is running true, but the cone's a little bit off. I don't know, that's probably just wishful thinking. But we're gonna try it. So first question is, can we touch it off without breaking it? I think so. I think we slowed it down enough that it'll be fine. It'd be very disappointing if this is what breaks it. I only have 2 of these. This is the roughing tool. I have 2 roughing tools, and then I have 2 finishing tools. Oh yeah, no problem. Alright, well, now we just need to see if machining breaks it. Here we go. Oh, that's terrifying. That is absolutely terrifying. Our coolant's missing. I'm going to pause it next time it comes up. I couldn't convince Fusion to not do dumb retracts, so we're kind of stuck with them. Alright, give me a dumb retract so I can move the nozzle. And it's gone. Shoot. So why is it gone? Alright, I've changed the code to be a little bit more conservative, and that's about all I could do. Oh, and I re-aimed the nozzle, so this tool will either make it or it won't. I won't know until it's done. Alright, we've got the green. Alright, we've got the green. Alright, we've got the green blinky. Did the tool survive? I think it did. Oh my gosh, the tool survived. I'm not going to show you what's under the milk because we're in NDA territory, but holy cow, that tool is still there. Attaboy. Okay, so I'm going to leave this tool holder in here and just swap out the Endmill. I have noticed that turning one of these tool holders can mess up my tool run out, and I have it dialed in like this. At least this part is dialed in this orientation, and if I take it out and put it back in, I'll have to do more dialing it in. However, if I just remove the tool from here, put the new one in, retouch it off, that should minimize the amount of dialing that is necessary. I don't want to get ahead of myself, but this part may ship today. I actually already contacted the customer and told him that I think it's going to be late, but I think I'm going to hit my deadline. I was a little too pessimistic after breaking that first tool. Oh, and for context, what I did to make it work. The first thing I did is I slowed down my RPM because I was afraid if the tool had some run out, and it's tilting like this a little bit, and then you spin it at 40,000 RPMs, it might go like that, and you might cause even more run out at speed. So I slowed it down from, I don't remember if I was running at 40K or 35K, but I slowed it down to 25K. I also halved my depth of cut, and I reduced my feed per tooth a little bit. So the overall effect was it went from like a half an hour tool path to like a 2.5 hour tool path, but the tool survived, and at the end of the day, the material being removed, that's what matters. I don't really care about cycle time as long as the part finishes and it's in spec, and I think we are on track. First rule of working with small tools is to not let the small units become meaningless to you. It's easy to think of this tool being only 5 thou smaller than the previous tool, but really that other tool was 50% larger than this one. That's like going from a 1/8 inch end mill to... That's like going from a 1/4 inch end mill to a 3/8 inch end mill, or from a 3/8 to a 1/4, I guess in this case. So like, that's a big difference with those tools, and it's easy to forget that it's that big of a difference with these tools. Another example is if this has 1 thou of runout, that's like having 50 thou of runout on a 1/2 inch tool, which is just obviously nutso. So you have to be extra super careful with measurements like that on this one. A thou doesn't seem like a big number until you're running a 10 thou end mill. Will the 10 thou end mill survive? It looks like it'll survive getting touched off. I'm glad I invested the time in fixing those macros. I have done something incredibly dumb. You remember how I said I had 2 of those 10 thou end mills? I can't find one. It's just gone. I've been looking for a solid hour, and I cannot find my backup 10 thou end mill. I don't know what I did with it. My best guess, there's like three things that could have happened to it. One, I could have put it down somewhere safe and then forgot about it, and I just haven't found it again. Hopefully it'll show up later. Option number 2, I put it down somewhere a little less safe. It rolled off the table and rolled off whatever I put it on and rolled under something. I've looked under all my tables. I can't find it. And I had a third option, but I forgot what the third option was. So I don't know, but I can't find it. It's gone. Oh, okay. Well, first of all, we're lucky that mill survived. First chance. Good job, mill. Attaboy. Good mill. Second thing that could have happened, or third thing, option 3 that could have happened is I may have left it on the table here and then it rolled into the chip tray. Considering I've been searching my shop, that one might be the most likely. But it doesn't matter. It survived. The part's ready to go on to Op 2, which is a pretty simple, just like make a step cylinder shape. So we're good. I can't believe this part has gone this smoothly, except for me losing the tool. We're on to Op 2. Again, nothing too crazy in this operation, just making it a cylinder. Over the last couple projects, I have learned that I have not been pushing this mill hard enough. I'm used to small mills and small tools, and I'm not used to, I guess that's not exactly a heavy duty mill, but I'm not used to mills that are heavier than my Tormach. And even the Tormach, I probably didn't push hard enough. So I'm learning, slowly, but I'm learning. I probably could have saved a lot of time on my last couple projects by just pushing my feeds and speeds harder. Good morning, everybody. I don't remember what the last thing I recorded was. I think it's becoming a common theme. Remember that part we were working on? Yeah, I scrapped that on Op 2. So later today, when the materials come in, we're gonna make that again. However, I wanna show you something. So there's the machines, and there is, well, not a wall. You can see right here the remnants. There used to be a wall here. That was the last evidence of this shop being a horse barn. That's what this was, I don't know, 10 years ago. There actually were horse stalls here, and there was stalls on both sides, and I think the previous owner put up that wall and the floor in there. But we have finally taken out that wall. Now, this room has always been the kind of dirtier stuff. We called it the dirty dungeon. And what we're gonna do is we're gonna put up a new wall here that is actually shifted over by 2 or 3 feet, making the machining side of the room bigger and making the dirty dungeon a little bit smaller. It'll come out to the same place that the powder coat booth does. And instead of it being, like horse slats, that's actually going to be a legitimate wall. It'll have some windows in it and a door. It'll have a door like this one, which will help with the sound. And more importantly, it'll keep all of the abrasives in here and away from my mills. And then also we're gonna put some ventilation in here. So if we're like running the sandblaster or whatever, we can make sure all that abrasive goes outside instead of back towards the machines. The air compressor is also gonna get its own little half hut. It's not really gonna get its own room, but it'll have some extra sound dampening to keep it a little bit quieter in here. And that is the thing I am most excited for, is getting the air compressor to be a little bit quieter. These lights here are gonna end up outside the wall, and we are gonna put in a couple nice high intensity LED panels, just like we have in the powder coat booth. And that'll provide much nicer light for things like deburring. So it'll be these same lights or ones that are similar in the dirty room. Yesterday I had the Tormach start munching through some of these big stainless steel blanks that I've been cutting over the last week or so. I had to do a little bit of tweaking. That machine definitely has some backlash in it that I need to fix before I run anything else. And there's a couple dimensions that I still need to check, but I'm pretty sure that today I'll be able to just start loading those and hitting go. The Op 1 takes about 2 hours each, and these are due in like a week or two, over a week. They're due in 10 days from today. And with 24 pieces with 2 hours each for Op 1, that's a pretty significant amount of runtime. And so the more I can get done before Christmas, the better. I think this will be one of the parts where I will use the Tormach for Op 1, and then I will switch them over to the Haas and do Op 2 on the Haas. And that way I can just have 2 spindles running, though I'm going to do all the Op 1s first because I have other parts that need to run on the Haas today. So while the Tormach is chomping away at that stainless, I am going to start on some Christmas gifts. Today is like December 22nd or something like that. We're coming up on Christmas. I have stuff scheduled for after Christmas, but I don't really have anything before Christmas. So I'm getting something done, which I'm happy enough with. And so the Tormach run is running on Zometry parts, so technically I'm making money. I can accept that and move on to some personal stuff. And this means you guys get to see the whole process on these. So I designed these, they're bottle openers. I designed these bottle openers to work with that same material that the Tormach is cutting, because I had like 3 extra feet of it, and it's a, it's 3/16 stainless, nothing wrong with that. Should make a pretty good bottle opener. So this is the design that I am going with for this bottle opener. This was inspired by a design that RJM CNC posted on Instagram. It is largely stolen from his design. He has an Etsy shop that I will link down below. Full credit to him. I will not be selling any of these as it is not my design completely. It is definitely a little bit adapted for me, but since I didn't design it from the beginning, I am not comfortable selling these. So basically it's just a big handle, and then it's got this little thing here that gives you leverage as this wedge here pops your bottle open. The cam for this is pretty simple. We're just gonna hold both operations in my mod vise. Op 1 consists of some roughing and then contouring the outside. Then we're gonna do a roughing surfacing pass, or a semi-roughing pass, and surface in everything smooth. And then we are going to do a pass here that's intentionally coarser, and this should leave us some nice parallel lines. So I want the surface texture to be left. I may even do some negative stock to leave to make these cuts more aggressive, or maybe do fewer of them. I really want this to be grippy and have some nice visual interest. And that's pretty much it for Op 1. I haven't done Op 2 yet, but Op 2, we're just holding this thing in a vise. The edges are flat. Not going to be doing anything crazy there. And I'll probably just copy paste the exact same tool paths, minus this outside contouring. So I'll just flip it over. We'll adaptive off this remaining hat of material here, and then we will give it some nice texture. I got a lot of suggestions about cutting this material on end, and you know what? With a sharp blade, it really did a good job. So that was the way to go. This was much faster, and I didn't break a blade on this one. Now, if you had a dull blade, the blade would wander like 3/4 of an inch across the whole width of this, and that would obviously be bad, but with a sharp blade, that was pretty good. So obviously 4 inches was too wide for a bottle opener, so now we get to cut this thing on end to make it 1.5 inches wide. And if it wasn't clear, this thing is gonna be a large, hefty bottle opener. It would probably weigh like a pound. It's gonna be awesome. Not the kind of thing that you would carry around in a pocket. This is the kind of thing you would put on a bar or in your kitchen cabinet to make it, like, it's the kind of thing you would have at like a party to open a bunch of beers. Or if you need to like bludgeon a bear or something, you could bludgeon a bear with it. It might be way too big, I don't know. I didn't 3D print it, which would have been the smart way of doing things. This is a personal project, and I really enjoy just winging personal projects. If I'm doing like a legitimate product development project, then this would be, you know, developed with a bunch of prototypes and the design would be perfected before we made one. Personal projects, nah. It's fun just to go for it and see what happens. So that's how you learn stuff. That's how you find unique things. And it doesn't have to come out right. There is no deadline other than Christmas. And if I miss it, oh well, nobody was expecting a 30-pound bottle opener as a stocking stuffer. So we'll see what happens. If it feels like this video's been a mess, that's because it has been. And that's because my life is kind of a mess at this point. This whole week has been a mess with the run up to Christmas. I haven't been filming as much as I would like because my dad has been in here working on the shop renovations, and I don't like to record when family's around. Just kind of, I'd rather be present with them than to always be talking to a camera. So that part that used the tiny tools, the first time I made it, I screwed it up. And so then I had to make it a second time. That just shipped yesterday, or the day before. Today is Christmas morning. And I was supposed to make some Christmas presents, but because I screwed up that part, I never got to make those. I had just kind of given up on making them, but I had a hard time sleeping. I was gonna say last night, but it's tonight really. It's like I got out of bed at 3:40 today just because I gave up on trying to sleep. And I guess we're gonna make those bottle openers now. So let's start by talking about how I scrapped that part. So the part basically looks like this. This is obviously just some aluminum scrap that I've stacked up because I can't show you the part. But there was a fat cylinder and a skinny cylinder. And inside the fat cylinder, there was the big, huge pocket that had the little teeny tiny tools that were cutting slots were way down here at the very bottom. So there was kind of a cone shape inside there. So the first time I made this part, I made it in this orientation. And I started by cutting out the cone and surfacing this first part of the cylinder. And then I flipped it over and faced off the back and finished this floor here and then the walls of this cylinder. I scrapped it after I'd finished everything, except I was doing a final finishing pass on this cylinder here. And it was a pretty tall stick out on that part, and especially for my machine with the ISO 20 taper, it just doesn't really like long engagement cuts. What happened is on that very last finishing pass, literally in the last 10 seconds of the part, the tool kind of grabbed this cylinder and just pulled it in like that. And that left a big ugly mark on the side here. That big ugly mark was enough to scrap the part, unfortunately, and that was the end of that. So why did that happen? One, I was using just a dumb, very long tool on this machine. The machine does not like that. Secondly, my soft jaws weren't deep enough. I don't know if I still have those around, but I think I had like a little over 1/8 of an inch, which is fine for most of the stuff I do. But because this was so tall, there was so much more leverage on it. And I think I had over tightened the vice jaws, which kind of caused them to deform a little bit. And I think that's why I ended up killing the part. Because of that, I went out and I bought a cheap torque wrench that I can use on my vice. I know I should have done that a long time ago. Hopefully that'll help me. Hopefully that'll prevent this happening in the future. Plus, I know just to make my soft jaws deeper on bigger parts. But anyway, now we can actually make some bottle openers. I don't think I have to set any tools for these. I should be able to just put them in and hit go. These are the blanks I'm starting with. I cut those the other day. This blank is a little bit oversized because the saw drifted, so I'm going to recut this down just a teeny bit smaller. But these should be fairly simple overall. So for this setup, we're back in the mod vise. I'm doing this one on parallels instead of in the step jaws. Because this part is long, I don't want these ends to be unsupported. Though it does look like we're going to have to move our flux vise here again, which is a little bit unfortunate, but it is what it is. It's just annoying to have to move again, because I'll have to put it back later. But fortunately, it's got dowels on the bottom, and it repeats really well. Alright, we should be good to go. Let's do single block, turn down our rapids, and start going through the code. On this one, I am pushing speeds and feeds a lot harder than I normally do, mostly because I just don't know how hard I can push this machine yet. So don't be surprised if we break this tool. Coolant reaimed. Alright, let's hope this doesn't break anything. Doesn't sound great, doesn't sound terrible. That didn't sound good. I bet the material's a little bit long. I think that's what happened there. Let's fix that. Well, that tool's gone. All right, new code. Let's try this again. Shallower depth of cut, less feed per tooth. This should be more conservative. Well, this should do. I guess we'll check back in a bit here when it's done. Alright, so the first op is done, and it is looking pretty good, I will say. The texture on the top is exactly what I was going for, kind of a nice little grippy texture. It is big. It was supposed to be big, and oh boy is it big. It'll definitely be satisfying in the hand. Now I need to flip it over and do op 2. The only difficult part about this is this top surface here is domed. It is not a flat rectangle, which means we can't just use parallels here. So what I'm going to do is I'm actually going to run my parallels like this, and that will kind of give it a height, and then I will reference off of, like, it will
the walls here are flat, and so they will align themselves to the hard jaws there, and that should give me a good enough reference for op 2. So normally for op 2 work like this, I set my Y on my vice jaw, then I have a work stop that I have touching the part here, and I set my X on that before I load the part, and my Z is on the top of the parallels. Well, my work stop is tied up at the moment. So what I'm going to do is I'm just going to put this parallel against the part here, and then use the wiggler to touch off against that.
Probably not the most precise way of doing things, but it's a bottle opener. My machine is an absolute mess, but I believe our part is done here, and it looks like it came out pretty well. But yeah, it's basically perfect. The blends are maybe slightly off, but overall that's what I was going for. Actually, even the blends aren't really off. They look the same on the top and bottom. So maybe my toolpath wasn't perfect, but that's pretty good. I'm happy with it. I might throw it on the buffing wheel to give it a little bit of a shine. It's definitely hefty, and the only thing I would change about this is I think I made the blade end, the business end, a little bit too thick. But yeah, that's not a pry bar. But yeah, that's a bottle opener. A big one, but it's a bottle opener. Well, this video has been a mess. My shop is a mess. This whole week has been a mess. But we got everything done that we needed to get done, and now I can go do Christmas with my family. So, see you guys.